Okay, so I'm really just going to go over a couple of concepts in logic. I think these are kind of foundational, and these are very important, therefore, to know in order to get into logic. So I'm looking at deduction, induction, the form of an argument, and validity. In this very order is how I'll go through them. So induction and deduction. Inductive arguments, they give conclusions which are likely true or are probable. On the other hand, deductive arguments give us certainty or truth by necessity. The first thing we can say is that if an argument is deductive, therefore giving us necessarily true conclusions, it is also inductive, because what is necessarily true also has a higher probability of being true. It's a bit trivial to make this point, but it's interesting to see that it doesn't work the other way around. Inductive arguments are not deductive. So what I mean by inductive, likely or possibly true, they start with specific premises, and then they form general conclusions. And deductive starts with general and forms specific conclusions. Again, what do I mean by that? So here's an example. This is a metal. This expands when heated, and therefore all metals expand when heated. So I've gone from the specific, this metal in my hand, this one expands, and I've concluded something very general. All metals expand when heated. This is most likely true, but it's not a guarantee. There's no guarantee that this is the case. On the other hand, deductive, if I say that all metals expand when heated, and I say that this is a metal, then I can say that this metal expands when heated. And I've gone from the very general to the very specific. Another argument, which is much less technical, is it is wet outside, therefore it is raining. This is likely true. There could be other reasons why it's wet outside. Yet again, I've gone from the specific to the general. Whereas if you look at the deductive, I have to give you the classic deductive argument. All humans are mortal, Socrates is a man, and therefore Socrates is mortal. Once again, I've started with the very general. The whole category of humans have the whole category of mortality. And I've ended with the individual Socrates, the person. In this course, we only look at deductive arguments. Inductive arguments can be statistics. 3 out of 4 people will do X in their lives. It doesn't mean if you have 4 people that 3 out of those 4 will do it. We don't deal with that in this course on logic, so only deductive arguments. Next, we have to look at the form of an argument. I simplify this a little bit. There is a lot to be said about forms. I've restricted myself to only that which is necessary for this course. It is an introduction, so I thought keep it introductory. So the logical structure is really the form of an argument, contrasted with the content of the argument, and of course what I mean by that. Here's an example. I only like good books. I like this book, therefore this is a good book. To get to the form of this argument, we can remove the content and so turn it into something a bit more symbolic. We have premise 1 and premise 2, and we have conclusion. We need to rearrange this a bit to get the form. Forms are of a specific structure. And here we can say all P's are Q. This is a P, so this is a Q. In other words, P is the group of things, books I like. Q is the group of things, good books. And here we have it. All the books I like are good. This is a book I like. This is a good book. So the form is all P's are Q. This is P. Therefore, this is Q. It kind of strips down what's happening with the logic in an architectural way within an argument without giving you any content. We don't know what P's are or Q's are, but we know the relationship between them. And that is what we're looking at in the form. So here we have one. All P's are Q. This is P. This is a Q. But there are, of course, other forms, many forms. I don't go through all of them. We have another form. All A are B. All B are C. And therefore, all A are C. An example, all dogs are mammals, all mammals are animals, and therefore all dogs are animals. That's a form of an argument. You can replace dogs and mammals and animals with other terms, of course, but this is just its scaffolding, its architecture. Another one is that all A are B, some A are C, and therefore some B are C. For example, all Spaniards are European, some Spaniards are teachers, and therefore some Europeans are teachers. This is just another form of an argument. And so this is what form of argument really means. The last term I'm looking at is validity. Validity states that an argument is valid if, double F, so if and only if, its conclusion follows from its premises. It's a little bit strange what I'm saying with this. So another way to formulate this is an argument is valid if and only if it is impossible for the conclusion to be false when all the premises are true. You can say, for example, that the premises force the conclusion, logical force, in a valid argument. So here we have again, if all A are B and all B are C, then it logically follows that all A are C. And you can think of this mathematically. If A equals B and B equals C, then A equals C. There's no way that all A are not C in a valid argument. So once again, the example, all dogs are mammals are animals, all dogs are animals. The conclusion, all dogs are animals, is forced. It follows from the two premises together. In other words, a valid argument has good form. So if a valid argument has good form, an invalid argument has bad form. So all A are B, all B are C, therefore all C are B. This is not a valid argument. It doesn't have good form. Because we can say, for example, if all dogs are mammals are animals, therefore all animals are mammals, and it doesn't hold. This kind of architecture to an argument doesn't work. The conclusion does not follow logically from the two premises together. If all A are B and all B are C, then all we can say is that all A are C, but not that all C are B. This just doesn't work logically. So it's invalid. Validity has an interesting relationship with truth, which I think brings out the meaning of validity a bit clearer. So all A are B, all B are C, therefore all A are C. This is valid. What about the following? All cars are bats, all bats are clouds, therefore all cars are clouds. What is the form of this argument? All A are B, all B are C, therefore all A are C. Is this a valid argument? And the answer is yes. Its logic is sound. Its logic is unsound, but the structure of the argument is true. If all A's are B and all B's are C, then all A's must be C. So it's valid. It's not true. Therefore, it's unsound. So really, the holy grail in logic is a sound argument because it's both valid and true. So you have the form, all A are B, all B are C, therefore all A are C, or any other valid form, and it's also true. This is a sound argument, and this is what we want in logic, deductive logic. That's why it has the stars.